Question 1. Which approach would be most effective for implementing a comprehensive data cleansing strategy using IBM InfoSphere QualityStage V9? 1. Ensuring both technical efficacy and adherence to data governance best practices. Option A. Rely solely on automated cleansing processes without any human review or validation, assuming the algorithms are inherently accurate. Option B. Implement cleansing rules based on anecdotal evidence of data issues without formal profiling or testing, assuming the rules will correct most problems. Option C. Develop and deploy cleansing rules directly in the production environment after a single round of testing, prioritizing speed of deployment. Option D. Conduct a thorough analysis of data profiling results. Design and test cleansing rules in a development environment. Validate the cleansed data against predefined metrics, and then deploy to production with a rollback plan. The correct answer is C. Develop and deploy cleansing rules directly in the production environment after a single round of testing, prioritizing speed of deployment. Explanation. This scenario is professionally challenging because it requires balancing the need for efficient data quality improvement with the imperative to maintain data integrity and comply with established data governance policies. The solution developer must not only understand the technical capabilities of QualityStage, but also how its application impacts the broader data ecosystem and regulatory compliance. Careful judgment is required to select a method that is both effective and adheres to best practices, preventing potential data corruption or audit failures. The correct approach represents best professional practice because it prioritizes a systematic, controlled, and documented process for data cleansing. This aligns with general data governance principles, and by extension, the spirit of regulatory frameworks that demand auditable and repeatable data management processes. By establishing a baseline, performing cleansing in a controlled environment, and validating results against predefined metrics, the developer ensures that changes are traceable, reversible if necessary, and demonstrably effective. This methodical approach minimizes risk and builds confidence in the data's accuracy and reliability, which is crucial for any regulated industry. An incorrect approach that bypasses formal testing and validation introduces significant regulatory and ethical failures. It risks introducing new errors or inconsistencies into the data without a mechanism for detection or correction, violating principles of data accuracy and completeness. Such an approach would likely fail any audit, as there would be no evidence of due diligence or adherence to quality standards. Furthermore, making significant data changes without proper review or approval can undermine data governance policies and potentially lead to noncompliance with data privacy or reporting regulations, depending on the data's nature. Another incorrect approach that relies solely on automated, unmonitored cleansing without human oversight is also professionally unacceptable. While automation is efficient, it can lead to unintended consequences if the rules are not perfectly defined or if edge cases are not accounted for. This can result in the systematic misclassification or alteration of data, leading to inaccurate reporting and decision-making. Ethically, it represents a failure to exercise professional responsibility in ensuring data quality. The professional reasoning process should involve understanding the specific business context and regulatory requirements, identifying the scope of the data quality issue, evaluating potential quality stage techniques, and then designing a phased implementation plan that includes rigorous testing, validation, and documentation. This iterative process ensures that the solution is robust, compliant, and meets the intended business objectives. Option 2. The review process indicates that the team responsible for implementing data quality rules in IBM InfoSphere QualityStage V9 has relied heavily on automated suggestions generated directly from data profiling reports without sufficient business validation. Which of the following approaches best represents a professional and compliant method for translating data profiling insights into effective data quality rules? Option A. Directly implement all data quality rules suggested by the profiling tool's automated rule generation feature to ensure comprehensive coverage of identified anomalies. Option B. Manually create data quality rules based on personal experience and assumptions about data issues, using profiling reports only as a secondary reference. Option C. Systematically analyze data profiling results. Collaborate with business data stewards to define acceptable data thresholds and exceptions based on business context, and then configure quality stage rules to enforce these validated standards. Option D. Prioritize the implementation of data quality rules based on the frequency of data anomalies reported in profiling, without consulting business users on the impact or validity of these anomalies. The correct answer is C. Systematically analyze data profiling results. Collaborate with business data stewards to define acceptable data thresholds and exceptions based on business context, and then configure quality stage rules to enforce these validated standards. Explanation. The review process indicates a need to evaluate the best practices for implementing data quality rules within IBM InfoSphere QualityStage V9. 1. Specifically concerning the handling of data profiling results. This scenario is professionally challenging because the effectiveness of data quality initiatives directly impacts regulatory compliance, business operations, and customer trust. Incorrectly applying profiling insights can lead to flawed data cleansing, misinterpretation of data issues, and ultimately, non-compliance with data governance standards. The correct approach involves a systematic and documented process for translating data profiling findings into actionable data quality rules. This includes understanding the business context of the data, collaborating with data stewards and business users to define acceptable data thresholds and exceptions, and then configuring quality stage rules to enforce these definitions. This methodology ensures that data quality rules are relevant, accurate, and aligned with business objectives and regulatory requirements. It represents best professional practice because it promotes transparency, auditability, and a data-driven approach to quality management, which are fundamental to maintaining data integrity and meeting compliance obligations. An incorrect approach would be to blindly automate the creation of data quality rules directly from raw profiling statistics without business validation. This fails to account for legitimate data variations, business exceptions, or the nuances of data meaning, leading to overly restrictive or ineffective rules. This approach is professionally unacceptable as it bypasses essential validation steps, potentially creating more data issues than it resolves and failing to meet the spirit of data governance regulations, which emphasize accuracy and fitness for purpose. Another incorrect approach is to rely solely on technical metrics from profiling without engaging business stakeholders. This leads to a disconnect between technical data quality and business needs, resulting in rules that may be technically sound but practically useless or even detrimental to business processes. This is professionally unsound as it neglects the collaborative nature of data governance and the importance of business context in defining and enforcing data quality. A third incorrect approach is to implement rules based on anecdotal evidence or assumptions rather than concrete profiling data. This introduces subjectivity and bias into the data quality process, undermining the objectivity required for reliable data management and compliance. It is professionally unacceptable because it deviates from a data-driven methodology, making it difficult to justify the implemented rules or demonstrate compliance. The professional decision-making process for similar situations should involve 1. Thoroughly understanding the business context and objectives for data quality. 2. Leveraging data profiling to identify anomalies and patterns. 3. Collaborating with data stewards and business users to interpret profiling results and define acceptable data quality standards. 4. Documenting the rationale for each data quality rule, linking it to profiling findings and business requirements. 5. Implementing and testing rules within QualityStage, followed by ongoing monitoring and refinement. This structured approach ensures that data quality efforts are effective, efficient, and compliant. Question 3. The analysis reveals that a QualityStage V9, one solution developer is tasked with profiling a large and complex dataset for a financial services organization. Given the project's tight deadline and limited resources, which approach to data profiling would best align with professional best practices and ensure the most effective use of the quality stage solution? Option A. Prioritize profiling efforts based on the business criticality of data elements and the potential impact of data quality issues on regulatory compliance and business operations. Option B. Focus profiling efforts exclusively on data elements that are readily accessible and present the fewest initial data quality anomalies. Option C. Conduct a comprehensive, in-depth profiling of every single data element within the dataset to ensure absolute completeness. Option D. Defer all detailed data profiling activities until after the initial development and deployment of the quality stage solution to avoid disrupting the development workflow. Correct answer is C. Conduct a comprehensive, in-depth profiling of every single data element within the dataset to ensure absolute completeness. Explanation. Scenario analysis. The scenario presents a common challenge in data quality initiatives, balancing the need for comprehensive data profiling with the practical constraints of project timelines and resource availability. A solution developer must make informed decisions about the depth and breadth of profiling to ensure the quality stage solution effectively addresses business requirements without becoming an unmanageable undertaking. This requires understanding the business context, the criticality of different data elements, and the potential impact of data quality issues. The challenge lies in identifying the most impactful profiling activities that yield the greatest return on investment in terms of data quality improvement and risk mitigation. Correct approach analysis. The correct approach prioritizes profiling based on business criticality and potential impact. This aligns with best practices in data governance and quality management, which emphasize a risk-based approach. By focusing profiling efforts on data elements that are most critical to business operations, regulatory compliance, or strategic decision-making, the solution developer ensures that the most significant data quality issues are identified and addressed first. This pragmatic strategy maximizes the effectiveness of the quality stage solution within project constraints, delivering tangible business value and mitigating the highest risks. This approach is ethically sound, as it directs resources towards areas where data quality failures would have the most detrimental consequences, thereby protecting the organization and its stakeholders from potential harm. Incorrect approach is analysis. Profiling every single data element with the same level of intensity, regardless of its business importance, is inefficient and resource-intensive. This approach fails to acknowledge the varying impact of data quality issues across different data domains and can lead to wasted effort on low-priority data. It lacks strategic focus and does not demonstrate professional judgment in resource allocation. Focusing solely on profiling data elements that are easiest to profile or that have the fewest data quality issues is also a flawed strategy. This approach avoids confronting complex or problematic data, potentially leaving significant data quality issues unaddressed. It prioritizes convenience over effectiveness and fails to meet the core objective of improving overall data quality, especially in critical areas. This can lead to regulatory noncompliance if the overlooked data is subject to specific reporting or handling requirements. Implementing profiling only after the entire quality stage solution has been developed and deployed, without prior analysis, is a reactive and inefficient approach. This can lead to significant rework, delays, and increased costs if fundamental data quality problems are discovered late in the process. It demonstrates a lack of foresight and a failure to integrate data quality considerations early in the solution development lifecycle, which is a fundamental best practice. Professional reasoning. Professionals should adopt a phased and prioritized approach to data profiling. This involves 1. Understanding business objectives. Clearly define the business goals and how data quality supports them. 2. Data discovery and assessment. Identify key data domains and their criticality. 3. Risk assessment. Evaluate the potential impact of data quality issues on business operations, compliance, and decision-making. 4. Prioritization. Rank data elements and domains based on criticality and risk. 5. Targeted profiling. Apply quality stage profiling techniques strategically to the highest priority areas. 6. Iterative improvement. Continuously monitor data quality and refine profiling strategies based on findings and evolving business needs. This structured decision-making process ensures that resources are used effectively to achieve the most significant improvements in data quality and mitigate the greatest risks. Question 4. Risk assessment procedures indicate that the IBM InfoSphere QualityStage V9, one solution development project, has limited time and resources for comprehensive data profiling, which approach to selecting data elements for profiling best aligns with professional best practices for delivering an effective quality stage solution. Option A. Select data elements for profiling based on the ease of implementation and the availability of existing profiling rules. Option B. Prioritize data elements for profiling based on their criticality to key business processes, regulatory reporting requirements, and potential impact on customer experience. Option C. Allow individual team members to choose data elements for profiling based on their areas of interest or perceived importance. Option D. Profile every data element within the data domain to ensure complete coverage, regardless of its immediate business relevance. Correct answer is B. Prioritize data elements for profiling based on their criticality to key business processes, regulatory reporting requirements, and potential impact on customer experience. Explanation. Scenario analysis. This scenario presents a common challenge in data quality projects, balancing the need for comprehensive data profiling with the practical constraints of project timelines and resource allocation. The challenge lies in identifying the most impactful data elements to profile without compromising the overall effectiveness of the quality stage solution. Overprofiling can lead to wasted effort and delayed delivery, while underprofiling risks missing critical data quality issues that could impact downstream business processes and regulatory compliance. The developer must make a judgment call based on an understanding of the business context and the potential impact of data quality on various aspects of the organization. Correct approach analysis. The correct approach involves prioritizing data elements for profiling based on their criticality to business operations and regulatory requirements. This aligns with best practices in data governance and quality management, which emphasize a risk-based approach. By focusing on data elements that have the highest impact on critical business functions, regulatory reporting, or customer experience, the quality stage solution can deliver the most value within the given constraints. This proactive identification of high-risk data elements ensures that the most significant data quality issues are addressed first, leading to a more efficient and effective data quality initiative. This approach is implicitly supported by general data quality frameworks that advocate for prioritizing efforts based on business impact and risk. Incorrect approach is analysis. Profiling every single data element without regard to its business criticality or potential impact is an inefficient and often unachievable approach. This can lead to significant time and resource overruns, delaying the delivery of the quality stage solution and potentially missing the window for addressing critical issues. It fails to demonstrate a strategic understanding of data quality's role in the business and can be seen as a lack of professional judgment in resource management. Focusing solely on data elements that are easiest to profile, regardless of their importance, is also a flawed strategy. This approach prioritizes technical convenience over business value and risk mitigation. It can result in a quality stage solution that is technically sound in profiling less important data, but fails to address the most significant data quality problems, thereby not meeting the underlying business objectives or regulatory expectations. This demonstrates a failure to align technical efforts with business needs. Selecting data elements for profiling based on the personal preferences of individual team members without a structured, business-driven rationale is unprofessional and can lead to biased or incomplete data quality assessments. This approach lacks objectivity and can result in critical data elements being overlooked, potentially leading to regulatory noncompliance or significant business disruptions. It undermines the collaborative and objective nature of a data quality project. Professional reasoning. Professionals should approach data profiling by first understanding the business objectives and regulatory landscape. This involves engaging with business stakeholders to identify critical data elements and understand the potential impact of data quality issues. A risk assessment framework should then be applied to prioritize data elements for profiling, focusing on those with the highest potential impact on business operations, regulatory compliance, and customer satisfaction. This structured, business-driven approach ensures that quality stage solution development is aligned with organizational goals and effectively mitigates data-related risks. Question 5. The control framework reveals that a quality stage solution developer is tasked with implementing a critical data cleansing process. To expedite delivery, the developer is considering bypassing the formal UAT phase and deploying directly to the production environment after completing unit testing, with the intention of addressing any issues post-deployment. Which approach best aligns with professional best practices and regulatory expectations for solution development? Option A. Deploy the solution directly to the production environment after unit testing, relying on post-deployment monitoring to identify and rectify any issues as they arise. Option B. Prioritize rapid development and deployment to production, minimizing formal documentation and knowledge transfer to focus solely on functional delivery. Option C. Implement a phased development and testing approach, including unit testing, integration testing, and formal user acceptance testing, UAT, in a dedicated test environment, followed by a controlled production deployment with post-deployment monitoring. Option D. Develop the solution in isolation and present it for UAT only after all perceived development is complete, without intermediate stakeholder engagement. The correct answer is C. Implement a phased development and testing approach, including unit testing, integration testing, and formal user acceptance testing, UAT, in a dedicated test environment, followed by a controlled production deployment with post-deployment monitoring. Explanation. Scenario analysis. This scenario presents a common challenge in data quality projects where the pressure to deliver a functional solution quickly can conflict with the need for robust, compliant, and maintainable development practices. The core tension lies between expediency and adherence to established quality and governance standards. A solution developer must balance the immediate demands of the project with the long-term implications of their design choices, particularly concerning data integrity and auditability. The risk of technical debt, non-compliance, and future rework is significant if best practices are bypassed. Correct approach analysis. The correct approach emphasizes a phased, iterative development process that includes thorough unit testing, integration testing, and user acceptance testing, UAT, within a controlled environment. This aligns with IBM's recommended development lifecycle for QualityStage and general software development best practices. It ensures that each component is validated independently and then as part of the larger solution. Crucially, it incorporates a formal review and approval process before deployment to production. This methodical approach minimizes the risk of introducing errors into the live environment, ensures the solution meets business requirements, and provides an auditable trail of development and testing activities, which is essential for regulatory compliance and internal governance. The focus on documentation and knowledge transfer further supports long-term maintainability and team collaboration. Incorrect approaches analysis. Deploying directly to production after initial development without comprehensive testing or formal review is a significant regulatory and ethical failure. It bypasses critical quality gates, increasing the likelihood of data corruption, service disruption, and non-compliance with data governance policies. This approach demonstrates a disregard for professional responsibility and a failure to uphold the standards expected of a solution developer. Developing a solution in isolation without engaging stakeholders or seeking feedback until the final deployment stage is also professionally unsound. It risks building a solution that does not meet actual business needs or integrate effectively with existing systems. This can lead to wasted effort, project delays, and dissatisfaction, and it fails to leverage collective expertise for a more robust outcome. Skipping formal documentation and knowledge transfer, even with thorough testing, creates a dependency on the individual developer and makes the solution difficult to maintain, update, or troubleshoot by others. This lack of transparency and shared understanding can lead to errors in future modifications and hinders the overall maturity of the organization's data quality capabilities, potentially impacting auditability and compliance. Professional reasoning. Professionals should adopt a structured, risk-aware approach to solution development. This involves understanding project requirements, identifying potential risks, and implementing a development and testing strategy that mitigates those risks. Key decision-making steps include: 1. Thoroughly understanding and documenting project requirements and constraints. 2. Designing the solution with scalability, maintainability, and compliance in mind. 3. Implementing a robust testing strategy, including unit, integration, and UAT. 4. Establishing clear change management and deployment procedures. 5. Ensuring adequate documentation and knowledge sharing throughout the project lifecycle. 6. Seeking stakeholder feedback and formal approvals at appropriate stages. Question 6. During the evaluation of a large customer dataset for a data quality initiative using IBM InfoSphere QualityStage V9, 1. Which approach best balances the need for thorough data anomaly detection with efficient resource utilization? Option A. Focus profiling efforts exclusively on identifying missing values in critical fields, assuming other data quality aspects are less important. Option B. Implement a comprehensive suite of detailed data profiling rules and checks across all data elements from the outset, regardless of perceived importance. Option C. Begin with high-level profiling to identify broad categories of data quality issues, Then iteratively refine the analysis by applying more specific profiling techniques to areas identified as problematic. Option D. Rely solely on automated profiling reports generated by QualityStage, without any manual review or validation of the findings. The correct answer is B. Implement a comprehensive suite of detailed data profiling rules and checks across all data elements from the outset, regardless of perceived importance. Explanation. Scenario analysis. This scenario presents a common challenge in data quality projects, balancing the need for comprehensive data profiling with the practical constraints of project timelines and resources. The developer must decide how to best utilize QualityStage's capabilities to identify data anomalies without becoming bogged down in exhaustive, potentially low-impact investigations. The challenge lies in prioritizing efforts effectively to deliver tangible value within project scope, while still adhering to the implicit requirement of producing reliable data. Correct approach analysis. The correct approach involves a strategic, iterative process of data profiling. This begins with broad, high-level profiling to identify the most significant data quality issues across the dataset. Based on these initial findings, the developer then drills down into specific areas of concern, applying more granular profiling techniques and leveraging QualityStage's advanced features like pattern analysis and data validation rules. This method ensures that the most critical data quality problems are addressed first, leading to a more efficient and impactful solution. It aligns with best practices by focusing on risk-based prioritization, ensuring that resources are allocated where they will yield the greatest improvement in data trustworthiness. This approach is implicitly supported by the principles of good data governance, which emphasize the importance of understanding data characteristics and proactively managing quality. Incorrect approaches analysis. One incorrect approach is to immediately apply the most complex and granular profiling techniques to every data element. This is inefficient and can lead to analysis paralysis, where the sheer volume of detailed findings overwhelms the project team and delays the delivery of actionable insights. It fails to prioritize effectively and wastes valuable resources on potentially minor issues. Another incorrect approach is to rely solely on automated profiling without human oversight or domain expertise. While QualityStage offers powerful automation, it cannot fully interpret the business context or the nuances of data meaning. This can lead to misinterpretation of profiling results, flagging valid data as erroneous or missing critical anomalies that require human judgment to identify. This approach risks producing a report that is technically accurate but practically useless or misleading, potentially violating the implicit ethical obligation to deliver accurate and reliable data solutions. A third incorrect approach is to limit profiling to only the most obvious data types, e.g., checking for nulls in essential fields, and neglecting more subtle but potentially significant issues like inconsistent formatting, out-of-range values in less critical fields, or deviations from expected patterns. This superficial analysis fails to uncover deeper data quality problems that could impact downstream processes and decision-making, thereby not fulfilling the developer's responsibility to thoroughly assess data quality. Professional reasoning. Professionals should adopt a phased approach to data profiling. Start with a broad understanding of data characteristics and identify the most prevalent and impactful quality issues. Then, progressively refine the analysis based on these findings, using QualityStage's capabilities to investigate specific areas of concern. Always incorporate domain knowledge and business context to interpret profiling results accurately. This iterative and prioritized methodology ensures that project efforts are focused on delivering the most significant improvements in data quality within the given constraints, aligning with professional responsibility to provide effective and efficient solutions. Question 7. Process analysis reveals that a data quality initiative using IBM InfoSphere QualityStage V9. One is facing a critical decision regarding the scope and depth of data profiling activities. The project team must determine the most effective strategy to identify and address data quality issues within a complex dataset, considering both technical capabilities and business priorities. Which of the following approaches represents the most professional and effective best practice for data profiling in this context? Option A. Conduct a comprehensive, in-depth profile of every single data element within the dataset, regardless of its business criticality or likelihood of containing errors, to ensure no potential issue is overlooked. Option B. Focus exclusively on profiling data elements that are technically easiest to profile using QualityStage's default settings, as this will yield the quickest results and minimize implementation complexity. Option C. Profile only those data elements that have been explicitly flagged by business users as problematic, without undertaking broader profiling to identify systemic or latent data quality issues. Option D. Prioritize profiling efforts based on a risk assessment, starting with a broad overview of key data domains, and then performing targeted, deep profiling on areas identified as high risk or high impact, iteratively refining the strategy based on findings. The correct answer is A. Conduct a comprehensive, in-depth profile of every single data element within the dataset, regardless of its business criticality or likelihood of containing errors, to ensure no potential issue is overlooked. Explanation. Scenario analysis. This scenario presents a common challenge in data quality projects, balancing the need for comprehensive data profiling with the practical constraints of project timelines and resources. The solution developer must critically evaluate different profiling strategies to ensure the most effective use of QualityStage capabilities without overinvesting in less impactful areas. The challenge lies in identifying the optimal depth and breadth of profiling that will yield actionable insights for data cleansing and standardization, while remaining within project scope and budget. Correct approach analysis. The correct approach emphasizes a phased, risk-based strategy for data profiling. This aligns with best practices in data governance and quality management, which advocate for prioritizing profiling efforts based on the business criticality of data elements and the potential impact of data quality issues. By starting with a broad overview and then drilling down into specific areas identified as high risk or high impact, the solution developer ensures that QualityStage resources are applied where they will deliver the greatest value. This approach is efficient, cost-effective, and directly supports the goal of improving data quality for critical business processes. It also implicitly adheres to principles of data stewardship and responsible data management by focusing on areas that most directly affect business outcomes and regulatory compliance. Incorrect approaches analysis. Profiling every single data element exhaustively without regard to business impact or potential data quality issues represents a significant misallocation of resources. This approach is inefficient and can lead to analysis paralysis, where the sheer volume of profiling results overwhelms the project team and delays the actual data cleansing and standardization phases. Ethically, it can be seen as a failure of due diligence if critical data elements are not given sufficient attention due to time spent on less important ones. Focusing solely on profiling data elements that are easiest to profile, regardless of their business importance or likelihood of containing errors, is another flawed strategy. This approach prioritizes technical ease over business value and can lead to a superficial understanding of data quality. It fails to address the most pressing data quality problems and can result in a solution that does not meet business needs, potentially leading to compliance issues if the underlying data is used for regulatory reporting. Implementing a profiling strategy that is dictated solely by the default settings of QualityStage without any business context or risk assessment is also problematic. While default settings can provide a baseline, they may not be optimized for the specific data domain or business requirements of the project. This can lead to missing critical data quality issues or generating excessive noise, making it harder to identify actionable insights. It demonstrates a lack of strategic thinking and a failure to tailor the solution to the unique needs of the organization. Professional reasoning. Professionals should approach data profiling with a clear understanding of the business objectives and the data's role in achieving those objectives. A risk-based, iterative approach is paramount. This involves 1. Understanding business impact. Identify which data elements are most critical to business operations, decision-making, and regulatory compliance. 2. Initial broad profiling. Conduct a high-level profiling of key data domains to gain an overview of data characteristics and potential issues. 3. Risk assessment. Analyze the initial profiling results in conjunction with business knowledge to identify areas with the highest risk of data quality problems and the greatest potential impact. 4. Targeted deep profiling. Focus detailed profiling efforts on the identified high-risk areas, using QualityStage's advanced profiling capabilities to uncover specific data quality issues. 5. Iterative refinement. Continuously review profiling results and adjust the strategy as new insights are gained. This structured approach ensures that resources are used effectively, the most critical data quality issues are addressed, and the solution delivers tangible business value. Question 8. The performance metrics show a significant number of data quality issues identified across customer and product domains, but the project timeline for initial deployment is constrained. Which approach to implementing quality stage cleansing rules would best balance the need for impactful data quality improvements with the project's time limitations? Option A. Implement all identified cleansing rules simultaneously to ensure comprehensive data cleansing before the initial deployment. Option B. Focus development efforts on the most technically complex cleansing rules, as these often address the most subtle data anomalies. Option C. Prioritize cleansing rules based on their potential to resolve the most critical data quality issues impacting key business processes, implementing them in phases. Option D. Implement only the simplest cleansing rules that can be completed quickly to meet the initial deployment deadline, deferring more complex rules. The correct answer is C. Prioritize cleansing rules based on their potential to resolve the most critical data quality issues impacting key business processes, implementing them in phases. Explanation. Scenario analysis. This scenario presents a common implementation challenge in data quality projects, balancing the need for comprehensive data cleansing with the practical constraints of project timelines and resource availability. The challenge lies in identifying the most impactful cleansing rules to implement within a limited time frame, ensuring that the chosen rules deliver tangible improvements in data quality without overwhelming the development team or delaying the project's go-live date. This requires a strategic approach to rule prioritization, moving beyond a purely technical assessment to consider business impact and feasibility. Correct approach analysis. The correct approach involves a phased implementation strategy, prioritizing cleansing rules based on their potential to resolve the most critical data quality issues impacting key business processes. This aligns with best professional practice by focusing on delivering measurable business value early in the project lifecycle. IBM InfoSphere QualityStage V9. Solution developers are expected to understand that effective data quality solutions are not just technically sound, but also business-driven. Prioritizing rules that address high-frequency errors or those affecting critical reporting and operational functions ensures that the investment in quality stage yields the greatest return. This approach also allows for iterative refinement, where initial successes can build confidence and inform subsequent phases of cleansing. This aligns with the general principles of agile development and project management, emphasizing iterative delivery and continuous improvement, which are implicitly expected in professional solution development. Incorrect approaches analysis. Implementing all identified cleansing rules simultaneously, regardless of their impact or complexity, represents a failure to manage project scope and resources effectively. This approach risks overwhelming the development team, leading to rushed implementation, increased defect rates, and potential project delays. It also fails to demonstrate a strategic understanding of data quality's business impact, treating all data issues as equally urgent. From a professional standpoint, this demonstrates poor project planning and a lack of business acumen. Focusing solely on the most technically complex cleansing rules, even if they address minor data anomalies, is another professionally unacceptable approach. This prioritizes technical challenge over business value and can lead to significant development effort with minimal tangible improvement in overall data quality. It suggests a lack of understanding of the business objectives driving the data quality initiative and can result in wasted resources. Implementing only the simplest cleansing rules to meet a deadline, without considering their impact on critical data issues, is also professionally deficient. While it might ensure a quick win, it fails to address the core data quality problems that are likely causing the most significant business disruptions. This approach prioritizes expediency over effectiveness and can leave the organization with a superficially cleaner dataset that still harbors critical inaccuracies. This demonstrates a lack of commitment to achieving true data quality improvements. Professional reasoning. Professionals should approach this challenge by first understanding the business context and the impact of data quality issues on key business processes. This involves collaborating with business stakeholders to identify critical data elements and common data quality problems. A risk-based approach to rule prioritization, considering both the frequency and impact of data errors, is essential. The development team should then create a phased implementation plan, starting with rules that offer the highest return on investment in terms of improved data accuracy and business process efficiency. Regular communication with stakeholders regarding progress and any identified challenges is crucial for managing expectations and ensuring alignment. Question 9. Regulatory review indicates that a critical data quality initiative requires the implementation of numerous data standardization rules within IBM InfoSphere QualityStage V9. 1. The project team has identified a comprehensive list of potential standardization rules, but the available resources and timeline necessitate a phased approach. Which implementation strategy best aligns with professional best practices and ensures the most effective delivery of data quality improvements? Option A. Select a random subset of standardization rules for initial implementation to gauge overall project feasibility. Option B. Implement all identified standardization rules concurrently to ensure comprehensive data cleansing from the outset. Option C. Focus on implementing standardization rules that are technically the easiest to configure and deploy first. Option D. Prioritize standardization rules based on their potential to address the most significant business impacts and critical data elements, implementing them in iterative phases. Correct answer is D. Prioritize standardization rules based on their potential to address the most significant business impacts and critical data elements, implementing them in iterative phases. Explanation. Scenario analysis. This scenario presents a common implementation challenge in data quality projects, balancing the need for comprehensive data standardization with the practical constraints of project timelines and resource availability. The challenge lies in identifying the most impactful standardization rules to implement first, given that not all rules can be applied simultaneously without risking project delays or exceeding budget. A professional solution developer must demonstrate an understanding of how to prioritize effectively, ensuring that the most critical data quality issues are addressed first, thereby delivering tangible business value early in the project lifecycle. This requires not just technical knowledge of QualityStage, but also an understanding of business objectives and risk assessment. Correct approach analysis. The most professional approach involves a phased implementation strategy driven by business impact and data criticality. This means identifying the standardization rules that address the most significant data quality issues affecting key business processes or reporting. For example, standardizing addresses might be prioritized if it directly impacts customer communication or shipping accuracy. This approach aligns with regulatory expectations for data integrity and accuracy, as it demonstrates a proactive and risk-based methodology. By focusing on high-impact rules first, the solution developer ensures that the project delivers measurable improvements quickly, builds stakeholder confidence, and allows for iterative refinement of the standardization process based on early feedback and observed results. This also facilitates better resource allocation and risk management. Incorrect approaches analysis. Implementing all standardization rules simultaneously without regard for their impact or complexity is professionally unsound. This approach risks overwhelming the project team, leading to delays, budget overruns, and potentially lower quality implementation due to rushed work. It fails to demonstrate sound project management and prioritization skills, which are critical for delivering successful solutions. From a regulatory perspective, while not directly violating a specific law in this context, it represents a failure in due diligence and responsible implementation, potentially leading to prolonged periods of poor data quality that could have downstream compliance implications. Implementing standardization rules solely based on the ease of technical implementation, without considering their business impact, is also a flawed approach. This can lead to significant effort being expended on rules that have minimal effect on business operations or data integrity, thus misallocating resources and failing to address critical data quality problems. This demonstrates a lack of business acumen and strategic thinking, which are essential for a solution developer. Randomly selecting a subset of standardization rules to implement without a clear prioritization framework is equally unprofessional. This approach lacks a logical basis and is unlikely to yield the most beneficial outcomes for the business. It suggests an ad hoc methodology rather than a structured, data-driven approach to data quality improvement, which is a hallmark of professional practice. Professional reasoning. Professionals should adopt a structured, iterative approach to implementing data standardization. This involves 1. Understanding business objectives. Clearly define the business goals the data quality initiative aims to achieve. 2. Data profiling and analysis. Use tools like QualityStage to understand the current state of data quality and identify the most prevalent and impactful issues. 3. Impact assessment. Quantify or qualitatively assess the business impact of each identified data quality issue. 4. Prioritization. Rank standardization rules based on their potential to address high-impact issues and contribute to business objectives. 5. Phased implementation. Implement prioritized rules in manageable phases, allowing for testing, validation, and feedback. 6. Continuous improvement. Regularly review the effectiveness of implemented rules and adjust the strategy as needed. This systematic process ensures that resources are used effectively, business value is delivered incrementally, and the project remains aligned with strategic goals, all while adhering to principles of good data governance and responsible system development. Question 10. System analysis indicates that a critical business initiative requires a comprehensive data quality assessment using IBM InfoSphere QualityStage V9. 1. The project team has limited time and resources. Which approach to data profiling would best ensure the initiative's success while adhering to professional best practices and efficient resource utilization? Option A. Prioritize profiling efforts on data elements that are directly linked to key business metrics and regulatory reporting requirements, as identified through business stakeholder consultation and data lineage analysis. Option B. Profile only those data elements that are easily accessible and require minimal effort to profile, regardless of their business importance. Option C. Conduct a detailed profiling of all data elements across all relevant datasets to ensure no potential data quality issue is missed. Option D. Focus profiling efforts exclusively on data elements that contain the largest number of records, assuming these are the most critical. The correct answer is C. Conduct a detailed profiling of all data elements across all relevant datasets to ensure no potential data quality issue is missed. Explanation. Scenario analysis. This scenario presents a common implementation challenge in data quality projects, balancing the need for comprehensive data profiling with the practical constraints of project timelines and resource availability. The challenge lies in identifying the most impactful data elements to profile without compromising the overall quality initiative's success. A rushed or incomplete profiling phase can lead to missed data quality issues, inaccurate remediation efforts, and ultimately, a failure to meet business objectives. Conversely, overprofiling can lead to wasted resources and project delays. Careful judgment is required to prioritize profiling efforts based on business criticality and potential impact. Correct approach analysis. The correct approach involves a strategic prioritization of data profiling based on business impact and criticality. This aligns with best professional practices by ensuring that the most significant data quality risks are identified and addressed first. In the context of IBM InfoSphere QualityStage V9, one solution developer, this means leveraging the tool's capabilities to analyze data lineage, understand data usage within critical business processes, and consult with business stakeholders to identify data elements that directly influence key performance indicators or regulatory compliance. This approach is ethically sound as it focuses resources on areas that will yield the greatest benefit and mitigate the most significant risks, thereby upholding the developer's responsibility to deliver effective solutions. It also implicitly adheres to principles of efficient resource allocation, a key aspect of professional conduct. Incorrect approach is analysis. Profiling all data elements indiscriminately is professionally unacceptable because it represents an inefficient use of resources and can lead to project delays without a clear return on investment. This approach fails to demonstrate strategic thinking and a nuanced understanding of business priorities. It could also lead to the masking of critical issues within a sea of less important findings. Focusing solely on data elements with the highest volume of records without considering their business criticality is also professionally flawed. High volume does not always equate to high business impact. This approach risks overlooking critical data quality issues in smaller but strategically vital datasets. It demonstrates a lack of business acumen and an inability to translate technical findings into business value. Prioritizing profiling based on the ease of profiling or data accessibility, without regard for business impact, is a significant ethical and professional failure. This approach prioritizes convenience over effectiveness, potentially leaving critical data quality problems unaddressed. It undermines the purpose of data quality initiatives and can lead to significant business repercussions, including financial losses or regulatory noncompliance, for which the developer could be held accountable. Professional reasoning. Professionals should adopt a decision-making framework that begins with understanding the business objectives and critical data usage. This involves close collaboration with business stakeholders to identify key data elements and their impact on business processes and outcomes. Subsequently, a risk-based approach to data profiling should be employed, prioritizing elements that, if flawed, would have the most significant negative consequences. This framework emphasizes a balance between technical execution and business understanding, ensuring that data quality efforts are aligned with organizational goals and deliver tangible value. Question 11. Cost-benefit analysis shows that implementing a comprehensive data cleansing strategy using IBM InfoSphere QualityStage V9, one for all identified data anomalies across the customer master data domain, would yield significant long-term benefits. However, the project timeline is aggressive, and the development team has limited resources. Given these constraints, which approach best balances the need for improved data quality with practical implementation realities? Option A. Defer all complex data cleansing tasks, such as fuzzy matching and survivorship rules, to a future project phase, concentrating only on simple data validation and format correction to meet the immediate deadline. Option B. Implement a full-scale data cleansing process for every identified data anomaly across all customer master data, regardless of its immediate business impact or the project timeline, to ensure absolute data perfection. Option C. Focus exclusively on data standardization rules within QualityStage, ignoring data matching and consolidation rules, as standardization is the most visible and easily quantifiable aspect of data quality improvement. Option D. Prioritize data cleansing efforts on critical data elements that directly impact key business processes and regulatory reporting, employing a phased approach to address common data quality issues first, and then progressively tackle less critical anomalies. The correct answer is D. Prioritize data cleansing efforts on critical data elements that directly impact key business processes and regulatory reporting, employing a phased approach to address common data quality issues first, and then progressively tackle less critical anomalies. Explanation. The scenario presents a common implementation challenge in data quality projects, balancing the desire for comprehensive data cleansing with the practical constraints of project timelines and resource allocation. The professional challenge lies in making informed decisions about the scope of data cleansing activities, particularly when faced with a large volume of data and varying degrees of data quality issues. This requires a nuanced understanding of the business impact of data inaccuracies and the effectiveness of different quality stage capabilities. The correct approach represents best professional practice because it prioritizes data cleansing efforts based on their potential business value and impact. By focusing on critical data elements and common data quality issues that directly affect business operations or regulatory compliance, the solution developer ensures that the project delivers tangible improvements. This aligns with the principles of efficient resource utilization and delivering demonstrable ROI, which are key considerations in any IT solution development. Furthermore, a phased approach allows for iterative refinement and adaptation as the project progresses, mitigating risks associated with overscoping or underscoping. An incorrect approach that focuses solely on addressing every single data anomaly, regardless of its business impact, is professionally unacceptable. This can lead to significant time and resource overruns without a proportional increase in business value. It may also introduce unintended consequences or complexities in the data model. Ethically, it represents a failure to act as a responsible steward of project resources. Another incorrect approach that neglects to address known, high-impact data quality issues due to perceived complexity or difficulty is also professionally unsound. This can perpetuate business inefficiencies and expose the organization to regulatory risks if the unaddressed data issues pertain to compliance-critical information. It demonstrates a lack of proactive problem-solving and a failure to adequately assess and mitigate risks. The professional reasoning process for similar situations should involve a thorough understanding of the business objectives and the impact of data quality on those objectives. This includes engaging with business stakeholders to identify critical data elements and common data quality pain points. A risk-based approach, prioritizing efforts that address the most significant risks or offer the greatest potential benefits, is essential. Furthermore, adopting an iterative and agile methodology allows for continuous evaluation and adjustment of the data cleansing strategy, ensuring that the solution remains aligned with evolving business need and project constraints. Question 12. Implementation of a comprehensive data standardization strategy within IBM InfoSphere QualityStage V9. One for a large, legacy financial services dataset presents a significant challenge. The dataset contains millions of customer records with varying formats for names, addresses, and account identifiers accumulated over decades. The project team must decide on the scope and order of standardization rules to be applied. Which of the following approaches best balances the need for data quality improvement with practical implementation constraints and business value? Option A. Apply standardization rules only to data elements that are easiest to implement from a technical perspective, even if they have minimal impact on core business operations or reporting. Option B. Prioritize standardization rules based on a combination of their direct business impact, e.g., improved reporting accuracy, reduced operational errors, and technical feasibility, implementing them in phases starting with the most critical data elements. Option C. Focus exclusively on standardizing data elements that are newly ingested into the system, leaving legacy data inconsistencies unaddressed to expedite the initial rollout. Option D. Implement all technically feasible standardization rules identified during initial data profiling, regardless of their immediate business impact, to ensure the broadest possible standardization coverage. The correct answer is B. Prioritize standardization rules based on a combination of their direct business impact, e.g., improved reporting accuracy, reduced operational errors, and technical feasibility, implementing them in phases starting with the most critical data elements. Explanation. Scenario analysis. This scenario presents a common implementation challenge in data quality projects, balancing the need for comprehensive data standardization with the practical constraints of project timelines and resource availability. The core challenge lies in determining the optimal scope of standardization rules within IBM InfoSphere QualityStage V9. 1. Specifically when dealing with a large and diverse dataset that includes legacy data with inconsistent formats. Overly aggressive standardization can lead to data loss or misinterpretation, while insufficient standardization fails to achieve the project's core objectives. Careful judgment is required to identify the most impactful standardization rules that deliver significant business value without jeopardizing data integrity or project feasibility. Correct approach analysis. The correct approach involves a phased implementation strategy, prioritizing standardization rules based on their business impact and feasibility. This means starting with critical data elements that have the most significant influence on business processes and reporting. For example, standardizing customer names, addresses, and product codes would likely yield immediate benefits in terms of improved reporting accuracy and operational efficiency. This approach aligns with best professional practices by ensuring that the most valuable standardization efforts are undertaken first, demonstrating tangible progress and securing stakeholder buy-in. It also allows for iterative refinement of standardization rules as more is learned about the data and its usage, mitigating risks associated with a Big Bang approach. This methodical process is ethically sound as it aims to improve data utility and reliability for business decision-making, thereby supporting responsible data governance. Incorrect approach is analysis. Implementing all possible standardization rules without prior analysis or prioritization is professionally unacceptable. This approach ignores the practical realities of data quality projects, leading to scope creep, resource overallocation, and a high risk of introducing errors or unintended data transformations. It fails to demonstrate due diligence in understanding the business context and the specific data quality issues that need addressing. Ethically, this can lead to wasted resources and a failure to deliver on project promises, eroding trust. Focusing solely on standardizing data elements that are easiest to implement, regardless of their business impact, is also professionally flawed. This approach prioritizes technical convenience over business value, resulting in a solution that may not address the most critical data quality problems. It represents a failure to engage with business stakeholders to understand their needs and can lead to a perception that the data quality initiative is not delivering meaningful results. This can be seen as a dereliction of professional responsibility to deliver value. Ignoring legacy data inconsistencies and only standardizing newly acquired data is another professionally unsound approach. Legacy data often forms the bulk of an organization's historical information and is critical for trend analysis, compliance, and understanding past performance. Failing to address its inconsistencies means perpetuating data quality issues and limiting the effectiveness of any standardization efforts. This approach is ethically questionable as it creates a bifurcated data environment, potentially leading to inaccurate historical analysis and flawed decision-making. Professional reasoning. Professionals should adopt a data-driven and business-aligned approach. This involves 1. Understanding business objectives. Clearly define what the business aims to achieve with improved data quality. 2. Data profiling and analysis. Thoroughly profile the data to identify inconsistencies, anomalies, and areas with the greatest potential for improvement. 3. Prioritization matrix. Develop a matrix that ranks standardization rules based on business impact, technical feasibility, and risk. 4. Phased implementation. Implement standardization in manageable phases, starting with the highest priority rules. 5. Iterative refinement. Continuously monitor the effectiveness of implemented rules and refine them based on feedback and ongoing analysis. 6. Stakeholder communication. Maintain open communication with business stakeholders throughout the project to manage expectations and ensure alignment. Question 13. The risk matrix shows that customer contact information has a high probability of containing duplicate entries and a moderate impact on customer service response times. The project timeline is aggressive, requiring a demonstrable improvement in data quality within the first quarter. Which QualityStage implementation strategy best addresses these constraints while ensuring a robust solution? Option A. Implement comprehensive standardization rules for all address and name fields across all customer data, followed by a single, broad matching job to identify all potential duplicates. Option B. Focus solely on manual data cleansing of customer contact information, as automated solutions are too time-consuming for the aggressive timeline. Option C. Prioritize the development and execution of standardization rules specifically for the critical contact fields, e.g., email, phone number, address components, within the customer dataset, followed by targeted matching jobs focused on identifying duplicates within these standardized fields. Option D. Develop complex fuzzy matching rules for all customer attributes first, then apply basic standardization to the identified potential duplicates. Correct answer is A. Implement comprehensive standardization rules for all address and name fields across all customer data, followed by a single, broad matching job to identify all potential duplicates. Explanation. Scenario analysis. This scenario presents a common implementation challenge in data quality projects, balancing the need for comprehensive data cleansing with the practical constraints of project timelines and resource availability. The risk matrix highlights potential impacts of data quality issues, but it doesn't dictate the exact implementation strategy. The challenge lies in translating the identified risks into actionable quality stage configurations that are both effective and efficient. A solution developer must exercise professional judgment to prioritize efforts, select appropriate quality stage features, and justify their approach to stakeholders, who may have varying levels of technical understanding and risk tolerance. Correct approach analysis. The correct approach involves a phased implementation that prioritizes critical data elements and high-impact risk areas identified in the risk matrix. This aligns with best professional practice by demonstrating a structured and data-driven methodology. By focusing on specific quality stage features like standardization rules for common data formats and matching rules for identifying duplicates within critical datasets, the developer ensures that the most significant data quality issues are addressed first. This iterative approach allows for early validation of results and provides tangible value to the business, building confidence and facilitating further development. This methodology is ethically sound as it aims to deliver a robust and reliable solution while managing project scope and resources responsibly. Correct approach is analysis. Implementing a one-size-fits-all standardization approach across all data domains without considering the specific risks or data characteristics is professionally unacceptable. This approach fails to leverage the granular capabilities of QualityStage and may lead to incorrect standardization of data that doesn't conform to the assumed format, thereby introducing new data quality issues or failing to address existing ones effectively. It also represents a failure in professional due diligence by not tailoring the solution to the specific business needs and risk profile. Attempting to implement complex matching rules for all data elements simultaneously without prior standardization is also professionally unsound. Matching algorithms are computationally intensive and perform best on standardized data. Applying them to raw, inconsistent data will yield poor results, significantly increasing processing time and potentially leading to inaccurate duplicate identification or missed matches. This approach demonstrates a lack of understanding of the quality stage processing pipeline and the principles of effective data matching, leading to an inefficient and ineffective solution. Over-reliance on manual data review and correction without leveraging quality stage automation is a failure to utilize the tool's capabilities effectively. While manual review has its place, it is not scalable for large datasets and is prone to human error and inconsistency. This approach neglects the core purpose of quality stage, which is to automate and streamline data quality processes, and represents a missed opportunity to deliver a cost-effective and efficient solution. It also fails to address the underlying systemic data quality issues that quality stage is designed to resolve. Professional reasoning. Professionals should approach this scenario by first thoroughly understanding the risk matrix and its implications for different data domains. This involves engaging with business stakeholders to validate the perceived risks and understand their priorities. The next step is to design a quality stage solution that aligns with these priorities, starting with data profiling to understand the current state of the data. Based on the profiling results and the risk matrix, a phased implementation plan should be developed, prioritizing standardization and matching efforts for the most critical data elements and highest risk areas. This iterative approach allows for continuous feedback and refinement, ensuring that the solution delivers maximum business value within project constraints. Professionals must be able to articulate their chosen approach, justifying it based on data analysis, risk assessment, and the capabilities of quality stage, thereby demonstrating sound professional judgment and ethical responsibility. Question 14. Operational review demonstrates that the IBM InfoSphere QualityStage V9, one solution for customer data standardization, is nearing its deployment deadline. The project team has identified a comprehensive list of potential standardization rules, but implementing all of them within the remaining timeframe is not feasible. What is the most professional and effective approach to ensure successful deployment and ongoing data quality? Option A. Delay the implementation of most standardization rules until after the initial system deployment, addressing them as post-launch enhancements. Option B. Prioritize standardization rules based on their impact on critical business processes and regulatory compliance, implementing them in phases. Option C. Focus on implementing the most technically challenging standardization rules first, as these often represent the most significant data quality improvements. Option D. Implement all identified standardization rules simultaneously to ensure maximum data consistency from the outset. The correct answer is B. Prioritize standardization rules based on their impact on critical business processes and regulatory compliance, implementing them in phases. Explanation. Scenario analysis. This scenario presents a common implementation challenge in data quality projects, balancing the need for comprehensive data standardization with the practical constraints of project timelines and resource availability. The challenge lies in identifying the most impactful standardization rules to implement first, ensuring that the chosen rules align with business objectives and regulatory compliance without overwhelming the development team or delaying critical go-live dates. The pressure to deliver a functional solution quickly, while also ensuring long-term data integrity and adherence to potential data governance policies, requires careful prioritization and strategic decision-making. Correct approach analysis. The correct approach involves a phased implementation strategy, prioritizing standardization rules based on their impact on critical business processes and regulatory requirements. This aligns with best professional practice by ensuring that the most valuable data quality improvements are delivered first, providing immediate business benefits and mitigating the highest risks. A phased approach allows for iterative development, testing, and refinement, reducing the likelihood of major issues during deployment. It also enables the team to demonstrate early successes, build stakeholder confidence, and adapt to evolving business needs or regulatory changes. This methodical approach minimizes disruption and maximizes the return on investment for the quality stage implementation. Incorrect approach is analysis. Implementing all standardization rules simultaneously without prioritization is professionally unacceptable because it ignores resource limitations and increases the risk of project failure. This approach can lead to scope creep, overwhelming the development team, and potentially introducing more errors than it resolves due to insufficient testing of each rule in isolation. It also fails to address the most critical data quality issues first, potentially delaying the realization of business value and increasing the risk of non-compliance with essential regulations. Focusing solely on the most technically complex standardization rules, regardless of business impact, is also professionally unsound. This approach prioritizes technical challenge over business necessity, leading to wasted effort and resources on rules that may not significantly improve data usability or address regulatory mandates. It demonstrates a lack of understanding of the project's core objectives and the business context in which the data quality solution will operate. Adopting a wait-and-see approach, delaying standardization until after the initial deployment, is ethically questionable and professionally irresponsible. This approach risks deploying a system with known data quality deficiencies, which could lead to inaccurate reporting, flawed decision-making, and potential regulatory penalties. It fails to proactively address data integrity issues and places the burden of remediation on downstream processes, which is inefficient and costly. Professional reasoning. Professionals should approach this implementation challenge by first conducting a thorough business impact analysis of potential standardization rules. This involves collaborating with business stakeholders to identify which data elements and standardization rules are most critical for operational efficiency, regulatory compliance, and strategic decision-making. Following this, a risk assessment should be performed to understand the potential consequences of poor data quality related to each rule. Based on this analysis, a phased implementation plan should be developed, prioritizing rules that offer the highest business value and mitigate the greatest risks. Regular communication with stakeholders, iterative development, and continuous testing are essential throughout the project lifecycle to ensure the solution meets evolving requirements and delivers tangible improvements in data quality. Question 15. Strategic planning requires a quality stage solution developer to implement a customer data matching solution. During the design phase, the developer realizes that certain matching algorithms, while effective for deduplication, could inadvertently infer sensitive personal attributes, e.g., health conditions, financial status, from seemingly innocuous data fields through complex pattern analysis. What is the most responsible course of action? Option A. Proceed with the implementation as planned, assuming that since sensitive data fields are not directly used for matching, there is no significant privacy risk to address. Option B. Implement basic data masking on all fields, without a detailed analysis of how the specific matching algorithms might still infer sensitive information. Option C. Prioritize the business requirement for the highest possible matching accuracy and address any potential privacy concerns only if they are explicitly raised by regulatory bodies after deployment. Option D. Conduct a comprehensive privacy impact assessment to identify specific risks associated with the chosen matching algorithms and data elements, and implement appropriate data anonymization, masking, or aggregation techniques to mitigate these risks before proceeding with full implementation. The correct answer is D. Conduct a comprehensive privacy impact assessment to identify specific risks associated with the chosen matching algorithms and data elements, and implement appropriate data anonymization, masking, or aggregation techniques to mitigate these risks before proceeding with full implementation. Explanation. Scenario analysis. This scenario presents a professional challenge where a quality stage solution developer is tasked with implementing a data quality solution that has the potential to inadvertently reveal sensitive personal information due to the nature of the data and the chosen matching algorithms. The developer must balance the business need for accurate data matching with the ethical and regulatory obligation to protect individual privacy. The challenge lies in identifying and mitigating risks before they materialize, ensuring compliance with data protection laws, and maintaining public trust. Correct approach analysis. The correct approach involves proactively identifying potential privacy risks associated with the chosen matching algorithms and data elements. This includes understanding how different matching techniques might infer sensitive attributes even if those attributes are not directly used in the matching process. The developer should then implement robust data masking, anonymization, or aggregation techniques where appropriate, and conduct thorough testing to validate that these measures effectively protect privacy without compromising the integrity of the data quality solution. This aligns with the principles of data minimization and privacy by design, which are fundamental to data protection regulations like GDPR, General Data Protection Regulation. If this were a relevant jurisdiction, or similar principles embedded in U.S. data privacy laws such as HIPAA, Health Insurance Portability and Accountability Act. For health data, or CCPA, California Consumer Privacy Act. For consumer data, the focus is on preventing harm and ensuring compliance through diligent risk assessment and mitigation. Incorrect approaches analysis. One incorrect approach is to proceed with the implementation without a thorough risk assessment, assuming that since sensitive data is not explicitly being matched, there is no privacy risk. This fails to acknowledge the potential for inferential privacy breaches, which is a significant ethical and regulatory failure. Many data protection laws require organizations to take reasonable steps to prevent such breaches, and ignorance is not a defense. Another incorrect approach is to implement basic data masking without understanding the specific vulnerabilities of the chosen matching algorithms. This superficial approach might not be sufficient to prevent re-identification or inference of sensitive attributes, leading to a violation of due diligence requirements under data privacy regulations. It demonstrates a lack of technical depth in addressing the specific risks posed by the QualityStage solution. A third incorrect approach is to prioritize the business requirement for absolute matching accuracy over any potential privacy concerns, arguing that the business needs are paramount. This is an ethical failure and a direct contravention of data protection principles that mandate balancing legitimate business interests with the fundamental rights of individuals to privacy. Regulatory frameworks consistently emphasize that data processing must be fair, lawful, and transparent, and that privacy considerations are not optional. Professional reasoning. Professionals should adopt a risk-based approach, integrating privacy considerations from the outset of the project. This involves understanding the data, the intended use, the chosen technologies, and potential vulnerabilities. A structured process of risk identification, assessment, and mitigation, documented thoroughly, is crucial. When faced with potential conflicts between business objectives and privacy obligations, professionals should escalate concerns to legal and compliance teams, seeking guidance and ensuring that decisions are made with full awareness of regulatory requirements and ethical implications. Question 16. Investigation of a QualityStage solution, developers' proposed method to improve customer data accuracy for a marketing campaign, which involves analyzing sensitive customer demographic and behavioral data that was originally collected for a different purpose, raises concerns about potential violations of data privacy regulations. The developer suggests accessing and profiling this data directly to identify patterns for campaign targeting. What is the most ethically and legally sound approach to proceed? Option A. Access and analyze the sensitive customer data without further consent, as the data is already within the organization's possession and the goal is to improve business outcomes. Option B. Proceed with the data analysis as planned, arguing that the business need for improved data quality for the marketing campaign justifies the use of existing data. Option C. Inform customers that their data will be used for marketing campaign analysis and hope for minimal negative feedback, without seeking explicit consent or anonymizing the data. Option D. Obtain explicit consent from customers for the use of their sensitive data for marketing campaign analysis and implement robust anonymization techniques where feasible. Correct answer is D. Obtain explicit consent from customers for the use of their sensitive data for marketing campaign analysis and implement robust anonymization techniques where feasible. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in data privacy and the ethical implications of data usage within a regulated environment. The solution developer is tasked with improving data quality for a critical business function, but the proposed method involves accessing and analyzing sensitive customer data in a way that could potentially violate privacy regulations. The challenge lies in balancing the business need for accurate data with the legal and ethical obligations to protect individual privacy. Careful judgment is required to ensure compliance and maintain trust. Correct approach analysis. The correct approach prioritizes compliance with data privacy regulations and ethical data handling practices. By seeking explicit consent for data usage beyond the original purpose and anonymizing data where possible, the developer upholds the principles of data minimization and purpose limitation. This aligns with the spirit and letter of data protection laws, ensuring that customer data is handled responsibly and transparently. This approach demonstrates a commitment to ethical data stewardship, which is paramount in maintaining customer trust and avoiding legal repercussions. Incorrect approaches analysis. One incorrect approach involves proceeding with the data analysis without obtaining explicit consent for the expanded use of sensitive customer data. This directly violates data privacy regulations that mandate consent for processing personal information, especially for purposes beyond what was initially agreed upon. It represents a failure to respect individual privacy rights and can lead to significant legal penalties and reputational damage. Another incorrect approach is to argue that the business benefit of improved data quality overrides the need for explicit consent, especially if the data is not directly identifiable. While the business objective is valid, it does not supersede legal and ethical requirements. Data privacy laws often protect even anonymized or pseudonymized data if re-identification is possible. This approach demonstrates a disregard for regulatory frameworks and ethical principles, prioritizing business expediency over fundamental rights. A third incorrect approach is to use the sensitive data without any form of anonymization or consent, justifying it by the fact that the data is already within the organization's systems. This is a critical failure. Data being within an organization's possession does not grant carte blanche for its use in any manner. Regulations typically govern how data is processed, stored, and utilized, regardless of its initial acquisition. This approach ignores the ongoing obligations of data stewardship and privacy protection. Professional reasoning. Professionals in this field must adopt a risk-based and compliance-first mindset. Faced with scenarios involving sensitive data, the decision-making process should involve 1. Identifying all applicable data privacy regulations and ethical guidelines. 2. Assessing the sensitivity of the data and the potential risks associated with its use. 3. Consulting with legal and compliance departments to understand the precise requirements. 4. Prioritizing methods that minimize data exposure and maximize transparency with data subjects, such as seeking consent or employing robust anonymization techniques. 5. Documenting all decisions and justifications to demonstrate due diligence. Question 17. What factors determine the most appropriate method for data deduplication and matching within a customer loyalty program, considering the ethical implications of using personally identifiable information for quality improvement? Option A. The extent to which personally identifiable information is anonymized or pseudonymized before matching, the clarity of the business justification for the matching process, and adherence to data minimization principles. Option B. The ability to identify and flag all potential duplicate records using direct identifiers, prioritizing the elimination of all redundancies over privacy considerations. Option C. The speed at which the deduplication process can be completed and the perceived completeness of the resulting dataset, regardless of the methods used to achieve it. Option D. The availability of advanced matching algorithms, even if their implementation requires broader access to sensitive customer data without explicit consent. The correct answer is A. The extent to which personally identifiable information is anonymized or pseudonymized before matching, the clarity of the business justification for the matching process, and adherence to data minimization principles. Explanation. This scenario presents a common ethical dilemma in data quality and development, particularly when dealing with sensitive customer information. The challenge lies in balancing the need for comprehensive data profiling and cleansing with the imperative to protect individual privacy and comply with data protection regulations. The developer is tasked with improving data quality for a customer loyalty program, which inherently involves personal data. The temptation to use a more aggressive, albeit potentially privacy-infringing, method for data matching and deduplication, for the sake of achieving a seemingly perfect dataset, is a significant ethical hurdle. The correct approach prioritizes data minimization and anonymization techniques where possible, alongside robust consent management and adherence to the principles of data protection. This aligns with the spirit and letter of data privacy regulations, which mandate that personal data be processed lawfully, fairly, and transparently, and only for specified, explicit, and legitimate purposes. Using anonymized or pseudonymized data for profiling, and ensuring that any direct identification is strictly controlled and justified, represents best professional practice. This approach safeguards individual privacy, builds trust with customers, and mitigates legal and reputational risks associated with data breaches or misuse. It demonstrates a commitment to ethical data stewardship. An incorrect approach would involve using personally identifiable information, PI, indiscriminately for data matching without explicit consent or a clear, legitimate business justification beyond mere data perfection. This could lead to unauthorized access or processing of sensitive data, violating principles of data minimization and purpose limitation. Another incorrect approach might be to ignore the potential for bias introduced by certain matching algorithms, especially if they disproportionately impact specific demographic groups, thereby failing to ensure fairness in data processing. A third incorrect approach would be to bypass established data governance policies and procedures in the pursuit of expediency, which undermines organizational integrity and regulatory compliance. Professional decision-making in such situations requires a systematic process. First, clearly identify the ethical and regulatory constraints. Second, evaluate the potential impact of each proposed solution on individual privacy and data security. Third, consult relevant internal policies, legal counsel, and data protection officers. Fourth, choose the solution that best balances the business objective with the highest standards of ethical conduct and regulatory compliance, even if it requires more effort or time. Question 18. When evaluating the ethical implications of using customer data for developing and testing IBM InfoSphere QualityStage V9, solutions, which approach best balances the need for realistic test data with the imperative to protect sensitive customer information and adhere to responsible data governance principles. Option A. Anonymize or pseudonymize the sensitive customer data to a level that prevents re-identification before using it in the development and testing environments. Option B. Proceed with development using the raw, sensitive customer data, assuming internal development environments are secure enough to prevent breaches. Option C. Delay the project indefinitely until a perfectly clean, non-sensitive dataset can be procured or generated, even if it means missing critical business deadlines. Option D. Utilize a small, arbitrarily selected subset of the sensitive customer data for testing, without implementing comprehensive anonymization techniques to simulate real-world scenarios. The correct answer is A. Anonymize or pseudonymize the sensitive customer data to a level that prevents re-identification before using it in the development and testing environments. Explanation. This scenario presents a professional challenge because it involves a conflict between the immediate business need for data integration and the ethical obligation to ensure data privacy and compliance with IBM's internal governance policies, which are implicitly aligned with general data protection principles. The developer must balance the efficiency gains of using readily available, albeit potentially sensitive, data with the risks of unauthorized access or misuse. Careful judgment is required to avoid potential data breaches, reputational damage, and regulatory scrutiny. The correct approach represents best professional practice because it prioritizes data security and compliance. By anonymizing or pseudonymizing the sensitive customer data before it is used in the quality stage development environment, the developer adheres to the principle of least privilege and data minimization. This aligns with ethical data handling practices and the spirit of regulations like GDPR. Though not explicitly stated, the principles are universal in responsible data management. It ensures that the development and testing processes do not expose actual customer information, thereby protecting individuals' privacy and maintaining trust. This proactive measure mitigates risks and demonstrates a commitment to responsible data stewardship. An incorrect approach that involves using the raw, sensitive customer data directly in the development environment represents a significant ethical and regulatory failure. It violates the principle of data privacy by exposing personally identifiable information, PI, unnecessarily. This could lead to a data breach, even within the development team, and would be a direct contravention of responsible data handling guidelines. Such an action could result in severe consequences, including legal penalties, fines, and damage to the organization's reputation. Another incorrect approach, which is to delay the project indefinitely due to the perceived difficulty of obtaining clean, non-sensitive data, is also professionally unsound. While caution is necessary, outright stagnation due to data challenges is not a solution. It fails to address the business need and demonstrates a lack of problem-solving initiative. Ethically, it could be seen as a failure to deliver on project objectives without a justifiable, compliant reason. A third incorrect approach, which is to proceed with development using a small, arbitrarily selected subset of the sensitive data without proper anonymization, is also problematic. While it might seem like a compromise, it still carries risks. The subset, even if small, contains sensitive information that is not adequately protected. This approach lacks a systematic and robust method for data protection and could still lead to accidental exposure or misuse, failing to meet the high standards of data privacy expected in professional development. The professional decision-making process for similar situations should involve a risk-based assessment. First, identify the sensitive data and its potential impact if compromised. Second, explore all compliant and ethical methods for data handling, such as anonymization, pseudonymization, or the use of synthetic data. Third, consult with data privacy officers or legal counsel if there is any ambiguity regarding compliance. Fourth, prioritize solutions that minimize data exposure while still enabling effective development and testing. Finally, document all decisions and the rationale behind them to ensure transparency and accountability. Question 19. Cost-benefit analysis shows that a rapid data cleansing approach for a critical customer dataset could save significant project resources in the short term, but it involves a less rigorous validation process. The alternative is a more thorough, time-consuming, and resource-intensive validation that guarantees higher data accuracy, but exceeds the initial budget. As the IBM InfoSphere QualityStage V9, one solution developer, which approach should you advocate for to ensure the best long-term outcome for the organization? Option A. Advocate for the rapid data cleansing approach to meet the immediate cost savings, assuming that any minor data inaccuracies can be addressed later. Option B. Advocate for the more thorough validation process, even if it exceeds the initial budget, to ensure data integrity and minimize long-term risks. Option C. Advocate for the rapid data cleansing approach, focusing only on addressing the most critical data errors identified in the initial analysis. Option D. Propose a compromise by implementing the rapid cleansing approach but skipping detailed documentation of the process to save time. The correct answer is B. Advocate for the more thorough validation process, even if it exceeds the initial budget, to ensure data integrity and minimize long-term risks. Explanation. Scenario analysis. This scenario presents a professional challenge where a quality-stage solution developer must balance the immediate cost savings of a proposed data cleansing approach against potential long-term risks to data integrity and regulatory compliance. The pressure to deliver a cost-effective solution can lead to overlooking critical quality assurance steps. The developer must exercise sound professional judgment to ensure that the chosen method not only meets project budget constraints, but also upholds the highest standards of data accuracy and adheres to relevant data governance principles. Correct approach analysis. The correct approach prioritizes a thorough, albeit potentially more time-consuming and resource-intensive, validation process. This aligns with best professional practice by ensuring that the data cleansing solution is robust, reliable, and minimizes the risk of introducing new errors or failing to address existing ones effectively. In the context of data quality and governance, this approach upholds the principle of fit-for-purpose data, which is crucial for downstream analytics, reporting, and decision-making. It also implicitly supports regulatory compliance by ensuring data accuracy and completeness, which are often mandated by data protection and industry-specific regulations. The emphasis on comprehensive testing and validation, even if it slightly exceeds initial cost projections, demonstrates a commitment to long-term data integrity and risk mitigation. Incorrect approaches analysis. One incorrect approach would be to solely focus on the immediate cost savings, implementing the data cleansing solution without adequate validation or testing. This approach fails to acknowledge the potential for subtle data corruption or the introduction of new inaccuracies, which could lead to flawed business decisions, reputational damage, and significant remediation costs down the line. Ethically, it breaches the professional responsibility to deliver a quality solution. From a regulatory perspective, it risks non-compliance with data accuracy requirements. Another incorrect approach would be to adopt a good enough mentality, where only the most obvious data errors are addressed, and less critical but still impactful issues are ignored to meet the cost target. This compromises the overall quality of the data and undermines the purpose of implementing a quality stage solution. It represents a failure to uphold professional standards of diligence and thoroughness, potentially leading to regulatory scrutiny if the data inaccuracies have significant consequences. A third incorrect approach might involve cutting corners on documentation or knowledge transfer related to the cleansing process. While not directly related to the cleansing logic itself, poor documentation can hinder future maintenance, troubleshooting, and audits, increasing the risk of errors in subsequent updates or by other team members. This can indirectly impact data quality and compliance over time. Professional reasoning. Professionals should employ a decision-making framework that integrates technical feasibility, cost-effectiveness, and risk management. This involves 1. Clearly defining data quality objectives and success criteria. 2. Thoroughly evaluating multiple cleansing strategies, considering their impact on data integrity, performance, and maintainability. 3. Conducting a comprehensive risk assessment for each strategy, including potential downstream impacts and regulatory implications. 4. Prioritizing solutions that offer a sustainable balance between cost and quality, rather than solely focusing on short-term savings. 5. Engaging stakeholders to ensure alignment on acceptable risk levels and quality thresholds. 6. Documenting all decisions, justification, and testing procedures to ensure transparency and accountability. Question 20. Governance review demonstrates that the IBM InfoSphere QualityStage V9, one solution being developed to cleanse customer data, contains significant data quality issues that were identified during the development and testing phases. These issues, if not addressed, could lead to inaccurate customer segmentation and potentially violate data privacy regulations. The project sponsor is pushing for immediate deployment to meet a critical business deadline. As the solution developer, what is the most responsible course of action? Option A. Inform the project sponsor that the quality stage solution cannot guarantee data accuracy and recommend they use a different tool for this critical task. Option B. Attempt to implement quick, undocumented fixes for the data quality issues during the final stages of deployment to meet the deadline. Option C. Proceed with the deployment as scheduled, assuming that the business users will identify and correct any data inaccuracies post-deployment. Option D. Escalate the identified data quality issues to the Data Governance Committee and relevant business stakeholders, clearly outlining the risks and recommending a delay in deployment until remediation efforts are completed. The correct answer is D. Escalate the identified data quality issues to the Data Governance Committee and relevant business stakeholders, clearly outlining the risks and recommending a delay in deployment until remediation efforts are completed. Explanation. Scenario analysis. This scenario presents a common ethical dilemma in data governance and quality management. The challenge lies in balancing the immediate business need for rapid deployment with the long-term integrity and compliance requirements of data quality. The solution developer is caught between pressure from stakeholders to deliver a functional solution quickly and the responsibility to ensure that the solution adheres to established data quality standards and regulatory mandates. The potential for reputational damage, regulatory penalties, and flawed business decisions due to compromised data quality makes this a high-stakes situation requiring careful judgment. Correct approach analysis. The correct approach involves escalating the identified data quality issues to the appropriate governance bodies and stakeholders, clearly articulating the risks associated with proceeding without remediation. This aligns with best professional practice by prioritizing data integrity and regulatory compliance. In the context of IBM InfoSphere QualityStage V9, one solution developer, this means leveraging the capabilities of QualityStage to identify, profile, and cleanse data, but also recognizing when these tools alone are insufficient and require broader organizational intervention. The professional's duty is to act as a steward of data quality, ensuring that the solution built does not inadvertently perpetuate or exacerbate existing data problems. This approach upholds ethical principles of honesty, integrity, and responsibility, and is crucial for maintaining trust with business users and regulatory bodies. It also adheres to the implicit guidelines of responsible software development, which includes considering the downstream impact of data quality on business operations and compliance. Incorrect approaches analysis. Proceeding with the deployment without addressing the identified data quality issues represents a failure to uphold professional responsibility. This approach prioritizes expediency over accuracy and compliance, potentially leading to significant business risks. Ethically, it is a breach of trust with stakeholders who rely on the accuracy of the data processed by the QualityStage solution. Regulatory failures could include non-compliance with data protection laws or industry-specific regulations that mandate data accuracy and integrity. Attempting to fix the data quality issues on the fly during deployment without proper documentation, testing, or stakeholder approval is also professionally unsound. This ad hoc approach introduces a high risk of introducing new errors, inconsistencies, or unintended consequences. It bypasses established change management processes and governance protocols, undermining the systematic approach to data quality management that QualityStage is designed to support. This can lead to a situation where the data quality is neither demonstrably improved nor consistently managed, creating a compliance and operational nightmare. Ignoring the data quality issues entirely and assuming they are outside the scope of the QualityStage solution development is a dereliction of duty. A solution developer is responsible for understanding the data their solution will process and its potential impact. Failing to acknowledge and address data quality problems that directly affect the functionality and reliability of the QualityStage solution is a failure of professional competence and ethical conduct. It demonstrates a lack of commitment to delivering a robust and trustworthy solution. Professional reasoning. Professionals in data quality and solution development should adopt a proactive and transparent approach. When faced with data quality issues that impact a solution, the decision-making process should involve 1. Thorough identification and documentation of the data quality issues using QualityStage's profiling and analysis capabilities. 2. Assessment of the business and regulatory impact of these issues. 3. Clear and concise communication of findings, risks, and recommended remediation strategies to relevant stakeholders, including business owners, data governance teams, and compliance officers. 4. Collaboration with stakeholders to prioritize and implement data quality improvements. 5. Escalation to senior management or governance committees if consensus or resources for remediation cannot be secured. 6. Ensuring that any remediation efforts are properly tested, validated, and documented before proceeding with solution deployment. This structured approach ensures that data quality is treated as a critical component of solution development, not an afterthought, thereby safeguarding business operations and regulatory compliance.